I've compiled the problems from Chapter 2 and done a little highlight of what is focused on in each problem and each section. So in a way, this is a review for the exam. However, this does not encompass every single thing that you'll need to know for this exam, because everything that you've learned in statics in terms of breaking down vectors, adding vectors, dealing with coordinate systems, all of that is still applicable. But in this chapter, there are just a few new things that are taught, and I want to highlight those and make sure that you're aware of what is there. For each of these problems, I have videos on YouTube that you can access. So if you have any issues with the concepts learned in the problem, check the videos out. They may help. Eventually, I'm going to redo the videos for these first few problems. I've learned a lot, and I think that I can make some better videos. So be aware that that is going to be coming, hopefully before this next exam. Let's dive right into this. In sections 1 and 2, we're looking at rectilinear motion, which is motion along a single path. However, that single path doesn't necessarily have to be straight, and that is why the term S is used a lot, because we don't always have a straight line. This becomes essential later on as we're looking at curves, because we need to be able to flatten out these curves and look at the motion along in time. So realistically, you're looking at this curve, but you're treating it as a straight line to solve for acceleration and velocity. But mostly the ideas that are focused on here is knowing how to integrate and derive between equations to solve for acceleration, velocity, distance, and time. Also, another important thing, especially focused on in problem 33, is being able to identify your initial and final conditions. And that's a theme that is carried on through the rest of this chapter. For a lot of the problems, the initial and final conditions are quite complicated. Also, there's the use of time in problems. And in 43, it really shows how that is useful. Some problems will ask for the value in time, and then you use that moving forward. So you're given one equation, you solve for time, and then you use time in a third equation. However, in problem 43, it shows you how you can directly link these two equations and not even have to deal with time at all. So you're using time, but you're not having to deal with that exact variable. And that's important later on as we move forward in different problems, because you can use this connection to simplify your problem greatly. Let's move on to sections 3 and 4. In 3 and 4, we're looking at planar curvilinear motion, which in this case is going to be in X and Y axes. Once again, you're looking at your initial conditions and final conditions and identifying those, and that is especially apparent in problem 55, where your final condition is this point where they cross. However, you still have to use the final conditions of where velocity of y is 0, but then after you use that information, you come back down to this other final condition. So you have to be aware of your conditions, or else they'll get mixed up and your problem will be messed up. As well as problem 68, you have interesting initial and final conditions, because your position is 0 initially, and it is also 0 at the end. And for problem 67, you're looking at the range, so wherever it lands again, that is your final position, and you need to be aware of what that value means in terms of your equations. So in this problem, or in these problems, everything from sections 1 and 2 you have to apply here, but you're also now substituting across the axes. So before, we primarily were using time to substitute it, but now we have our y and x, and we're still using time, but you just have more equations to deal with. Also, remember that even though we usually have gravity as acceleration in the y, and usually the acceleration in the x direction is 0, that is not always the case, and you cannot always assume that. For this problem here, especially, we have the wind. So if you were to use an equation that was previously derived that had the assumption that the x acceleration is 0, you're not going to be able to solve for it. So be sure that you're aware of where your equations are coming from and that they line up with the problem that you're looking at. In section 5, we are now given normal and tangential. So everything before comes into play, but we have a new coordinate system. And this new coordinate system is dynamic. If you have a curve and at this position of t1, you have normal and tangential, later on in time, it's going to be different position, and therefore the coordinate system is going to rotate. And that's actually going to make this a lot easier because you don't have to change your x and y every single time. However, you do have to deal with your x and y and vector components because sometimes you're given information in x and y, or in this case, just y, and you have to convert it to normal and tangential components. And being able to do vector manipulation is essential, especially at the end of this problem where you have a normal and a y, and you have to use that information to solve for a t. So be sure you're very, very comfortable with vector components and using them to find more values. In section 6, we're now looking at polar coordinates, which is e theta and er. This is a new coordinate system that's pretty similar to what we were looking at before, but there are different equations for acceleration. So remember, a normal is v squared over r, or rho, or capital R, depending on what that value is. And we can still use that equation here, but now we have the introduction of theta, theta dot, and theta double dot. So be sure that you're very, very familiar with all the equations for acceleration. Once again, we're looking at a lot of vector components. That's essential for problem 130, going back and forth between all of the values. They all have relationships to each other using vector components. And here in chapter 7, we have that exact same thing, except that we've added a third dimension. Now, instead of just theta and the height, or r, you now have phi as well. So be sure that you know how to coordinate the given information beta. You'll need to convert that into phi and theta. But the basics of this section are similar to what you see before in chapter 6. Finally, Chapter 8 and 9 is relativity. This is a little bit different than everything you've seen before. It's not just rotating between coordinate systems. It's actually relating 3 different coordinate systems because you have A, you have B, and then you have the ground that's not moving. Again, you have A, B, and the ground that's not moving. And you'll need to use relative equations and concepts to convert these 2 particles to one another. Don't forget videos on YouTube. Email me if you have any questions.